how do you create the training data sets that improve the performance? And I think one of the things that you're credited with is coining this term Goldilocks data for ideal training data sets. Yeah, tell us a little bit more about Goldilocks training data sets. Why are they
Yeah.
important, and what are they? First of all, let's define.
Yeah. So maybe it will help to sort of explain the kind of techniques we use to train modern models. You've probably heard of what we call supervised fine tuning. We have a bunch of pictures and they're labeled cat and dog, and you give them to a model and say, learn to tell the difference between a cat and a dog. Models are pretty good at this. But this is essentially memorizing and then expanding on the patterns in your training data. This does not tend to teach this sort of creativity, this sort of introspection over a set of APIs that we need. So we use what's called reinforcement learning, right? And the data set that we use for reinforcement learning is what we call an RL gem or an RL environment, right? The pieces of this, we start with what we call a world state, okay? So one of our toy examples is actually a bank. We don't train much on this one, but it's nice to explain. So the world state here is a bank with a bunch of bank accounts, right? Those bank accounts are checking accounts and savings account and mortgages and credit cards. They have balances, they have owners, sort of get as much richness there as you can, right? We then also have MCP clients, right? So these MCP, I said client. This is always screwing me up. MCP servers, right? So an MCP server is exposes tools that can be used to manipulate the world state, right? We then we write our own MCP client that uses those MCP servers, those tools, to manipulate world states. We take that whole package. We sort of call this our training harness. We take a prompt and we put it in, right? A prompt might be pay off my credit card bill, and if there's enough money left over, move up to $1,000 to savings, right? Something like that. Even that statement is a little ambiguous. Does he mean leave $1,000 in checking? Does he mean, what does it mean to have enough money? There's always some ambiguity, right? But we give that prompt to the world state. We let the system chew over it. Let the training agent chew over that thing. And eventually it produces an output, right? A transcript of actions it took and maybe some statement at the end, back to me saying I did it, right? We pass those to a grader. And the key detail here, the grader is able to go and look at the world state. So if I say pay off my credit card bill, I'm not asking whether the agent said it paid my credit card bill. I'm going to look at the balance. Did it actually move the correct amount of money, right? Now, once we've done that, for every example, we get a score. Often this is just a binary score, 0 or 1, but you can do sort of a partial credit, if you will, depends on the scenario. And we pass that to our loss function, sort of our actual model updating logic. GRPO is the sort of the open source version of this that was popularized by DeepSeek, and you can go and run this on a suitably powerful laptop even. That updates the model. Now, you asked about Goldilocks data. There's this subtle, tricky, hard thing embedded in this problem, which is that the world state and the prompt that I use needs to be just the right amount of hard. If I run the same thing through my model multiple times, right? Often we'll do 16 or 64 times, same problem, right? So same world state, same question. If every time I get the same answer and it's a pass, that's too easy. I can't actually train on that, right? Because I don't have any sort of difference to compare to. If every time I get fail, right, that's too hard. I don't have any examples of how to do it correctly, so I can't train a model to do it correctly. So the model or the training data needs to be just right. That's the Goldilocks part, right? It needs to be just right in the sense that sometimes I get a success, sometimes I get a failure when I sample. Then I've got enough signal to compare, well, what happened? What did the model do when it succeeded? What did the model do when it failed, right? And I can compare those two and sort of train a model away from failure and towards success. But the key thing is I need a mixture of successes and failures when I run this system in a batch. That is the hard problem. That is what my team does all day, is how do we generate data that is just hard enough, right? That is in this Goldilocks zone of difficulty so that we can actually improve the model, right?
Yeah, this is really, really fascinating. On the TELUS Digital side, it's taken us a lot of, taste tests to get just the right blend of difficulty in terms of a high value data set. And, eventually, I think, when we're at sort of the ASI state, you get your prompt can be, as you've described, as simple as you are a helpful agent. The model
Mhm.
it knows you well enough, it understands your intent and does the rest. But kind of in the meantime, getting that right blend is certainly tricky.
Very challenging.
Business